Hello, everybody, and welcome to another edition of Tech Talks with Wallace Ennis. My name is John Hanley, and I'll be your instructor today. We'll be talking about variable refrigerant flow, system selection, and application, and we'll also talk about a little install today, and we're obviously going to be talking about our Panasonic VRF line. Like I said, my name is John Hanley. I work in the Plan and Spec department for Wallace Ennis. I've been with the company a little over a year, and I have 5 years industry experience with a focus on ductless and VRF. Okay, before we get started, I just want to share a little bit about the company with you guys. Wallace Ennis is a hydro, air, and mechanical service and sourcing rep. We service the tri-state area, New Jersey, Long Island, 5 boroughs, lower New York State, and lower Connecticut. We've been around for 95 years. We have 72 employees spread out over 2 locations, one in Plainview, Long Island, and the other in Franklin Lakes, New Jersey. We service the tri-state area, like I said. We try to live by the 360 experience at Wallace Ennis. This essentially means we cover all aspects of a mechanical project. We try to complete our projects in accordance with all our customers' expectations. The 360 experience covers residential and commercial buildings, new construction, and retrofit. We offer services to developers, engineers, GCs, construction managers, facility managers, contractors, and wholesale distribution. The services we provide through the 360 experience include HVAC and domestic plumbing design, system sizing, product and system selection. We do training. We also do startup, commissioning, and we also offer extended warranties. The 360 experience also covers our capabilities to manufacture prefabricated skid packages. Our goal is to reduce installation costs for our customers. We try to accelerate project timelines and offer more flexibilities to customers through our engineering and design. We are also able to meet unique requirements with our manufacturing of the skid packages, and we, Wallace Ennis, quarterback that entire process for you. This is just a look of the lines manufacturers that we represent. Tisdale Manufacturing in the middle here is our company that heads up the skid packages design and manufacturing. You can see Bell & Gossett. We rep Lochinvar, high efficiency boilers, Panasonic, Semline, Gould. So just a little snapshot of what we do and who we represent. All these manufacturers are mature industry leaders in the marketplace, and they're big players in the tri-state area. Okay, just a little outline of what we're going to talk about today with regard to Panasonic VRF system selection and application and also installation. We're going to talk about smart oil management. We're going to take a look at our condensing units. We're going to take a look at the indoor units. We're going to talk about wiring, controls, and refrigerant accessories. Okay, Panasonic VRF smart oil management. So what is this? Panasonic, different or separate from the other VRF manufacturers, puts a lot of emphasis on oil management. In any heat pump or air conditioning system, it's essential to return oil to the compressor, that the oil is in the system for velocity to help the refrigerant travel through the refrigerant line, the piping circuit. So this is very important. If we're not returning oil to the compressor, we're doing damage to the compressor, because the compressor needs oil in order to function properly. So 3-stage oil management. Panasonic uses a 3-step process in order to retrieve oil. So what they do is they have a compressor oil sensor. They sense oil levels. When oil levels are low, they're able to go into forced recovery mode and retrieve oil from the indoor piping circuit and the indoor units to bring oil back to the compressor. They also use a balancing tube. So when our VRF condensers are linked together, we have a balancing tube that is basically an oil tube. So if one compressor and one condenser is low on oil, we can borrow oil from another condenser that we're connected to via the balancing tube. So it's basically a shared oil system with the balancing tube. And we also use an oil separator. So what our oil separator is, it's like a reservoir, and it's connected to all of our compressors, and it is basically a reservoir for oil to keep. It's basically like a storage tank, okay? And so when the compressor needs oil and we're low, we can also steal oil from this oil separator here. So 3 ways, 3-step, 3-stage oil management. Panasonic VRF takes this very seriously. You'll get a longer life out of your compressors when you have a smart oil management system as a part of your VRF system. Obviously, nobody likes to replace compressors, so this will lengthen the life immensely of a compressor and of a system. Okay, Panasonic Mini VRF LE heat pump system. So this is our first offering of our VRF lineup. This is our 208, 230 volt single phase unit. We offer it in 3 ton and 4.5 ton, 36,000 and 52,000 BTU options. It is a heat pump only. The total piping length that we can connect to this system is 556 feet. Our elevation differences for our refrigerant piping is 164 feet when the condenser is on the roof, and when the condenser is on the ground outside, it's 131 foot that you can pipe up a building inside. The height difference, high versus low on the indoor units. So our highest indoor unit can only be 49 feet above our lowest indoor unit on one condenser, pipe back to one condenser. We can connect 9 indoor units max to the 52,000 BTU unit, and we can connect 6 indoor units max on the 36,000 BTU unit. This is our Panasonic Ecoeye ME series. The ME series is a heat pump system. These systems are 208, 230 volt, or 460 volt, and they are 3-phase power only. We offer this ME heat pump in 6 ton to 30 ton options. There are 2 cabinet sizes. This is a picture of the larger cabinet size, and then there's a smaller cabinet size for the 6 through 9 ton. We jump up to the larger cabinet size after that. So you can connect 64 indoor units max to the 30 ton, and the elevation differences versus on the roof versus on the ground are the same, 164 versus 131. The total amount of piping that we can put onto this system or connect the system, used for the system, is 3,280 feet, total feet. And the height difference for the highest indoor unit versus the lowest indoor unit is the same. It's 49 feet. Okay, this is our Panasonic Ecoeye MF heat recovery system. We offered this system in 6 to 30 ton options. It's 208, 230 volt, or 460 volt, and it's 3-phase power only. A heat recovery system is different than a heat pump system. Heat recovery systems allow you to simultaneously heat and cool spaces at the same time. So we have indoor units that are going to be connected to this condensing unit. Some of our indoor units with a heat recovery system can be in heating mode, and other indoor units connected to the system could be in cooling mode. So a good application for a system like this would be a lot of offices in an office building. You have some people in an office who are hot, they want to have AC on, and then you have other workers in other offices who are cold who want to put the heat on. With this system, you can achieve that all pipe back to one condensing unit. So all the other manufacturers can do that, but this is the way of the future when it comes to heating and cooling spaces. The max amount of indoor units on the 30-ton is the same at 64 indoor unit max. The elevation differences are the same, 164 feet when the condenser's on the roof that you could pipe down. When the condenser is on the floor, you can pipe up to a highest elevation of 131 feet. The total amount of piping length for this system is less. It's 1,640 feet, total feet. And the height difference between the highest indoor unit versus the lowest indoor unit is the same at 49 feet. Okay, this slide here is our Ecoeye outdoor unit installation location. So we want to be very careful where we install our condensing unit, our outdoor unit. We got to keep an eye out for certain things. So we want to avoid heat sources such as or exhaust fans. We want to avoid damp, humid, or uneven locations. Okay, what we want to do is we want to choose a place that's as cool as possible. We want to allow enough room for air intake for future service, and we want to make sure that we're able to anchor properly to reduce noise and vibration. So there's a few ways that we can make sure that we have a safe and secure outdoor unit location. So we can use an equipment pad. This unit is sitting up on an equipment pad. There are also stands that you can put the condensing unit on that can get the unit up 12 feet, 12 inches or 18 inches. Those are very popular, or also you can do a cheaper option. You could do cinder blocks. You can make sure that the spot where you're putting this is going to be level with the cinder blocks. Obviously, all options are a little bit different in price. The big thing with the stands or the wall bracket is we want to get heat pumps and heat recovery units up off the ground. We want to avoid the snow line because these coils in here, if they freeze, they will break. So we want to get these units up off the ground, and we do that with a stand, a wall bracket, or you could use equipment rails, or you can use an equipment pad on top of some cinder blocks to get it up a foot or 2 feet. Okay, our LE Mini Ecoeye condensers are the first offering. This is the single phase unit, 36,000 or 52,000 BTUs. This is the clearances, minimum clearances for our unit. So when we have air discharging out the side this way, away from a wall, this is a L-shaped wall here. We have 8 inches from the side of the unit, and then we have 6 inches clearance from the coil side. This would be the coil side, this would be the fan side. Okay, and then if we want to put units next to each other, we need 12 inches a foot minimum between units. If we have air discharging towards a wall, we want to see 40 inches for that. Obviously 8 inches from the side, just like here. If we have 2 units back to back, the coil sides are facing each other, we could a minimum clearance of 16 inches. If we have a unit discharging into a coil side, so we got the fan side blowing into the coil side, we want to see a minimum of 80 inches. Anything less than 80 would be problematic. This unit would not heat or cool because it's got this unit blowing into it. Okay, these are our outdoor unit minimum clearances for the ME and MF unit. So our 3-phase heat pump and our 3-phase heat recovery unit. We want to watch out for our service panel. We want to be mindful where we're installing, what side of the unit the service panel is on. So when you got a wall here like this, we want to see 20 inches minimum, 12 inches from the side of the unit, and 12 inches from the back of the unit. These units discharge, the fan is on top, and they blow up, so you don't have to worry about blowing into another unit like you would with the LE unit. Okay, this is just a snapshot of all of our indoor units that we can connect to these condensers. All of our air handlers, our indoor air handlers, are 208, 230 single phase power. We'll start up here with the MD unit. The MD unit is a 30 by 25 ceiling cassette. It's a one-way airflow, perfect for small spaces. This unit comes with a lift mechanism for condensate removal. Next we have the MK, which is the standard high wall mount unit. It has a long life washable filter. This does not have a built-in pump. If you needed a condensate pump, you can get a third party for this. Next is the MU. This is a 3x3 four-way ceiling cassette. This also has a built-in lift mechanism for condensate removal. Here we have the MT, which is our ceiling suspended unit. This unit is equipped with a fresh air knockout, perfect for reintroducing fresh air to a space if that's needed. It's perfect also for classrooms or long hallways. This has a long throw. This could throw air, supply air up to 40 feet. That's why it is good for long hallways or corridors. In the middle here is our ME indoor unit. This is our high static concealed ducted unit, suitable for long duct runs. It's also capable of a 0.7 external static pressure. So this has a big fan in it. So if you wanted to put a good amount of ductwork on this, you can do that. Over here is our MF unit. This is our median static concealed ducted unit, capable of a 0.6 external static pressure. This is the most popular unit for engineers and architects installing in New York City, in new office buildings or new buildings that, aesthetics are a big deal. Architects like this unit the best because it is ducted. You can't see it. Next we have our MM, which is our low static concealed ducted unit. This is low profile for tight ceiling applications. It is not good for long duct runs. The fan in this unit is small, so you cannot put a lot of ductwork on this. You got to watch your static pressure and your CFMs that you need for each space that you're using for this. This is good for maybe a large residential, like a master bedroom with a walk-in closet or a master bath. The MM also has a built-in lift mechanism for condensate removal. So does the MF unit. And then next is the MR. This is our floor-mounted unit, similar to a radiator. And the MP is the same unit, just with the decorative panel. You see these in colleges, office buildings, high-rises, or churches. This is a good unit to replace the kind of radiator look if it's an old structure like a church or something like that. Also available but not on this slide is our MY unit. Our MY unit is a 2x2 four-way ceiling cassette, similar to the MU, but it is 2x2 instead of 3x3. And also we have an MVA, high static multi-position traditional style air handler. It has an ECM fan motor, and it has a filter rack, and it has also optional electric heat kit for supplemental heat. Okay, Ecoeye air handlers power requirements. So what this is showing here is how we power and wire our indoor units. So our indoor units are powered with 208 230 volt single phase power. We recommend a disconnect switch, that's third party, before we go into wire in our power to our indoor unit. So all of our power goes to L1 and L2. Okay, and we also have a ground for this. And then U1, U2 is our communication. That's our SNet control wiring. We recommend 18 gauge 2 conductor shielded wire. Okay, so this is going to create our link from our condensing unit. Say our condensing unit is over here. We wire our condensing unit to all of our indoor units. So we wire from the condenser to the first indoor unit, and we connect to U1, U2. Then from here, we go to our next indoor unit and we go to U1, U2 as well. And all of the indoor units that we have connected to, say, a given system. And then in the indoor unit, you have R1, R2, and that is for your 18.2 shielded wire that would wire to your wall-mounted thermostat or remote controller. Okay, so this is an example of correct wiring setup for an Ecoeye unit. Okay, so we got U1, U2 at the condenser. You got U1, U2 at your indoor unit, all of your indoor units. So this is a good snapshot of what the communication link is going to look like. You're going to go from your condenser to your first indoor unit, second, third, fourth, fifth. Okay. We want to use always 18 gauge 2 conductor shielded wire. These are our control options for our indoor units or our system controls. So the most standard, most popular controller is the CZRTC4. This is the standard programmable wall-mounted thermostat. This is a wired option. This is basically the same thing. This is like the 2.0 version of the standard. This is the CZRTC5. This is the high-spec remote. You can do programming with this. You could also do troubleshooting. You can have access to error codes if you need to do service. If something is not acting properly, this gives you those capabilities. This is our simple remote. All these are wired options. This is the simple CZRE2C2. You have no programmability. This is just on, off, modes, fan, change the louver direction. So very simple, basic remote. Good for somebody who does not want a lot of bells and whistles. This here is our remote sensor, remote air temperature sensor. So if we don't want a thermostat at all in the space, we just want to sense temperature, we could have this remote sensor. This could work well with these two guys, which are system controllers. So if we want to just control all of our units with remote air and we want to have one central controller, this would be a good option. And like I said, these guys are our system controllers. So this guy is the CZ64ESMC2U. This control has the ability to control 64 indoor units, okay? And you could obviously do some programming with this as well, but this is a system controller. This would control other thermostats like these guys. So it would override anything that would be in the space. And this is the intelligent controller. This unit will control all of your indoor units or your condensers. You can connect this to BACnet, a front end. You could do remote sensing. This can control up to 256 indoor units or individual condensing unit, but 256 refers to the indoor units that it can control. So this is our intelligent controller that Panasonic has for all of our VRF indoor units. Okay, just want to talk about refrigerant piping procedures. We always want to use insulated, soft drawn, flexible copper for your refrigerant runs. It has to be ACR grade, obviously. The refrigerated lines, we want both of our liquid and suction lines insulated. You see a lot of VRF manufacturers, they want to see white, the easy pull line sets for ductless. That's the best option to use. A lot of times it's 1/2 inch insulation, but in New York City now, I think there are some areas where they're asking for 1 inch thick insulation on your line sets. You can use hard ACR copper, but you have to use long radius elbows when you're using hard pipe. When you're brazing, especially hard pipe, you want to use 15% silver solder, and you want to use a nitrogen purge. You can use a 1.5 to 2 psi purge through your pipe swat when you're brazing. Isolation ball valves are also a good option. You can isolate branches in indoor units if you ever needed to do service, but isolation ball valves are not a necessity. This is just a picture of what it would look like if you did not braze with purge your lines with nitrogen while brazing. All this sediment is oxidation from the flame, from the torch, from brazing. When you purge with nitrogen, this is what the inside of the pipe looks like. Doesn't look like there was ever a torch on there. If you do this and you do not purge with nitrogen, all of this black soot is going to get cleaned by the refrigerant. It's going to clean the inside of this pipe to look like that, and all this black soot is going to wind up back in the compressor. And if you get enough of it, it's going to turn to sludge, and it's going to lock up your compressor eventually, and you're going to need to replace your compressor, and that's going to be a nightmare. So always purge with nitrogen. This is a look at our distribution joint. So these distribution joints are used for connecting our indoor units for heat pump systems. What we do is we pipe from the outdoor unit inside the building, and when we want to pipe to multiple indoor units, we use this joint. This termination is going to pipe to one indoor unit, and this termination here is going to allow us to pipe to the next air handler. So from our condenser to our next air handler to one room for the first air handler here. And we want to position these joints at a 15 to 30 degree angle, meaning that this end would be up 15 to 30 degrees for proper refrigerant flow through this joint. So that's the orientation we're looking for, is 15 to 30 degrees. This is just a picture of what these joints would look like on a job installed, kind of a schematic look here. When we're connecting to heat pump systems, ME systems, we would use a joint that would basically be inverse to all these guys in order to connect the refrigerant pipes of the two condensing units that we're twinning together to increase our capacity. And this is basically how we would connect all of our refrigerant piping for our indoor units, okay? So this is just one refrigerant line. For a heat pump system, we have two refrigerant lines. We have a liquid line and a suction line. The diagram just shows one of the two, but just imagine like there's two, a liquid line and a suction line. So everywhere where there's a joint, there's going to be two joints. And you can see the connections here for liquid and suction line for our refrigerant piping. Okay, Ecoeye heat recovery solenoid valve kit. So for our heat recovery systems, simultaneous heating and cooling, we need to use solenoid valve kit boxes. So this is a picture of our single zone solenoid valve box. Okay, this is the single. We have a 4-zone box, we have a 6-zone box, and we have an 8-zone box. Okay, and basically what this is doing is it's taking 3 pipes from the condensing unit, okay, because our heat recovery systems are a 3-pipe system from the condensing unit. So we accept 3 pipes at this box, and this box converts those refrigerant pipes into two pipes, and that there where we would pipe to our indoor units from there. So this is the single zone look, but we have a 4, a 6, and an 8, so we can connect up to 8 indoor units back to one box. So this is part of the magic as to how we do simultaneous heating and cooling with one MF heat recovery system. Okay, all of our solenoid valve kit boxes come with a relay box for electrical and communication. So we want to install our relay boxes close to our indoor units because our connection from the relay box to the indoor unit is only a 5-foot cable. So we can wire from our solenoid valve box, our 5-wire thermostat wire. We have 98 feet to play with, wire to our relay box, and then from there we're all set up and we can wire to our thermostat. Okay, leak check procedure. Very, very, very important when doing commissioning. When you're all done with your install, before you do startup, to leak check your refrigerant pipes to make sure there's no leak. That's one of the biggest problems with VRF and ductless is refrigerant leaks in your piping system. So it's very, very important that you do the work on the front end to make sure that you're not going to have to deal with leaks in the future. So what we do is we do a 3-stage leak check. So we pump the system up with nitrogen to 200 pounds and we leave it for 8 hours. After that, we pump it up to 300 pounds and we leave it for another 8 hours. And then the 3rd stage, we pump it up to 450 pounds and we leave that for 24 hours. It is a bit time consuming, but when you're doing a large installation in a large building, this is a corner that you just cannot cut, because dealing with leaks at some point in the future is very, very, very problematic. Okay, and here we are talking about evacuation procedure. So we want to clean the inside of our refrigeration pipes. So the way that we do that is we do a evacuation with our vacuum pump, and we have our digital gauges here to see where we're at in microns. So we pump the system down to 500 microns. This will ensure that we remove any moisture or debris inside of the piping system so that we have a clean piping system then we can charge up with refrigerant. Okay, Panasonic provides us, Wallace Ennis, with a system called the Pack Design System. So it's a design software that allows us to do system layouts for design, sizing, engineering, all the work on the front end to make sure that we're meeting a building or a customer's needs with our VRF, our Panasonic VRF. We can map out piping and wiring, and we can offer schematic layouts. Basically, what we see here is we see all of our line sizes, so there'll be a letter associated wherever it is on the schematic. It'll tell us our liquid and suction line, or if we're doing a heat recovery system, we'll have liquid, suction, discharge. We'll have 3 pipes. Sometimes it'll tell us what size copper that needs to be. We can enter our distances of our piping runs. That'll help us to figure out how much additional refrigerant we need to add to a system, what our charge is going to be, and it will also allow us to see what our D rate is, because the further we pipe away from the condensing unit, the indoor units, the less capacity we're going to be able to get from what it's rated at. So that's very, very important to see, and this program, this software, allows us to lay all that out so we can see it for design, all the front end work that we need to do. Okay, and that's all I had for everybody today. We appreciate you guys. We appreciate your business. Obviously, Panasonic VRF obviously has a lot of options, a lot of we could be a solution for a lot of applications out there in the tri-state area. If anybody needs any help with VRF or layout, a VRF or has an opportunity, application that thinks would be a good fit for Panasonic VRF, please let us know. We obviously have a lot of capabilities here with engineering and with design and with the software that we have with the pack design. We'll be able to help you out. So we'd love to partner with you guys for your next VRF project. And here I just put up some information for you guys so you can see our address in Plainview and Franklin Lakes. If you need to call any of the offices, I could be reached here. This is my email address. We could also be reached by our estimating and inside sales inboxes as well. We know this is a difficult time. Everybody's doing remote meetings during this pandemic, so we wish everybody well, and we hope that everybody stays safe. Thank you very much.